Ever wondered about the vastness of the universe and our place in it? This question has puzzled humanity for centuries. We've looked up at the night sky, marveled at the stars, and yearned to understand our cosmic home. But how can we grasp the enormity of the cosmos when the universe's timeline stretches back nearly 14 billion years? Enter the cosmic calendar. This is a conceptual tool that helps us visualize the universe's epic history by compressing it into a single year. Picture this. If the entire history of the universe was condensed into one calendar year, then every month would represent about 1.2 billion years. Every day would signify around 40 million years. And each second? That would encompass about 500 years of cosmic history. This fascinating concept was popularized by the renowned astronomer Carl Sagan in his television series, Cosmos. He realized that our human brains struggled to comprehend the vast expanse of cosmic time. So he proposed a scale that could make this enormous timeline more digestible. The cosmic calendar is an extraordinary tool that allows us to place key events in the universe's history on a timeline that makes sense to us. This calendar begins on January 1st, with the birth of the universe, also known as the Big Bang. As we move through the months, days, and seconds of this cosmic year, we encounter the formation of galaxies, the birth of stars, and the emergence of life on Earth. But where do we, humans, fit into this grand timeline? Well, if you take the entire history of the universe and condense it into 1 year, all of recorded human history would fit into the final seconds of December 31st. That's a humbling thought, isn't it? So, let's delve deep into this cosmic journey as we explore the key events that have shaped our universe, from its fiery birth to the present day. Imagine, if you will, a calendar where every second represents thousands of years. Our cosmic journey begins with a bang, the Big Bang to be precise. This event wasn't a typical explosion as we understand them, but rather an unfurling, a sudden expansion of everything from a single, infinitely dense point. This moment of singularity, occurring roughly 14 billion years ago, marked the inception of all we know: space, time, matter, and energy. In the blink of an eye, the universe expanded faster than the speed of light. This period, known as cosmic inflation, saw the universe grow from subatomic to golf ball-sized. As the cosmos cooled, the fundamental forces we're familiar with today, gravity, electromagnetism, and the strong and weak nuclear forces, began to take shape. The universe continued to cool, and within the first 3 minutes, protons and neutrons began to fuse, forming the first atomic nuclei in a process called nucleosynthesis. Yet, the universe was still too hot and dense for atoms to form, and it would take about 380,000 years for the cosmos to cool enough for hydrogen and helium atoms to stabilize. As the universe expanded and cooled, matter began to clump together under gravity's pull to form the first stars and galaxies. These celestial objects lit up the universe, ending what cosmologists call the cosmic dark ages. Let's pause for a moment and imagine. This intricate dance of forces and particles, this grand cosmic ballet, is happening in a universe that's just a few minutes old on our cosmic calendar. It's breathtaking, isn't it? Now, fast forward to today, and we're still feeling the reverberations of these early cosmic events. The light from the Big Bang, stretched and cooled, forms the cosmic microwave background, a kind of cosmic afterglow that permeates all of space. Just like that, in a burst of energy, the universe was born. Now, how do we make sense of billions of years, you may ask? Well, that's where the cosmic mapping comes into play. With the universe clocking in at around 13.8 billion years old, our human brains struggle to comprehend such an enormous span of time, so scientists have come up with a clever way to make it more digestible. Imagine if we took all of cosmic history, from the Big Bang to this very moment, and compressed it into a single year. This is the essence of the cosmic calendar, a tool that turns the vast expanse of cosmic time into something we can understand. The cosmic calendar begins on January 1st, the moment of the Big Bang, and ends on December 31st, right now. Each month, each day, each second represents a specific amount of cosmic time, allowing us to pinpoint when key events in the history of the universe occurred. Picture this. If the Big Bang happened at the stroke of midnight on January 1st, our Milky Way galaxy wouldn't form until May. The Earth, it doesn't come into existence until late September. And humans, we only appear in the last seconds of December 31st. The cosmic calendar helps us grasp the sheer scale of cosmic time and our tiny, yet significant place within it. It allows us to see how short human history is compared to the vastness of the universe. Despite our late arrival in the cosmic year, we have been able to unravel the mysteries of the universe, a testament to our curiosity and ingenuity. Every second of the cosmic calendar represents tens of thousands of years, every minute millions, and every hour represents hundreds of millions of years. It's a humbling and awe-inspiring perspective, isn't it? By compressing billions of years into a familiar human-scale frame of reference, the cosmic calendar allows us to better understand the history and chronology of our universe. It's a vivid demonstration of the fact that we are a part of an incredibly vast, ancient, and ever-evolving cosmos. And thus, we have the cosmic calendar, a tool to understand the history of everything. On this scale, every second represents thousands of years. Imagine that. Every tick of the clock, a leap through millennia. That's the breathtaking scale of the cosmic calendar, a concept that compresses the entire history of the universe into a single year. Consider January. The universe bursts into existence with the Big Bang, an event so cataclysmic it sets the stage for everything that follows. The first stars ignite in February, casting their radiance across the cosmos. The galaxies, these vast islands of stars, begin to form in March. As we move into April and May, the universe continues to evolve, with galaxies clustering together, creating the cosmic web we see today. By June, our own Milky Way galaxy has taken shape, a swirling disk of stars and gas, home to countless worlds yet to be formed. July and August are relatively quiet, cosmically speaking. The universe continues its expansion, galaxies drift apart, and new stars are born and die in fiery supernovae. But it's in September, specifically on the 9th day, that our own solar system is born. October is a month of change. On the 2nd day, the Earth forms. By the 25th, life emerges, simple and primitive, but life nonetheless. November sees the evolution of these simple life forms into complex organisms, culminating in the first multicellular life. And then comes December. On the first day, the first dinosaurs roam the Earth. They rule for nearly the entire month until, on the 26th, a massive asteroid strike leads to their extinction. Finally, on the last day of the year, in the last few seconds before midnight, humans appear. All of recorded human history, from the ancient civilizations to the present, happens in the blink of an eye. From the formation of galaxies to the emergence of life, every moment on this calendar is a testament to the universe's grandeur. This is the scale of the cosmic calendar. It's a humbling reminder of our place in the cosmos and a testament to the beauty and complexity of the universe we inhabit. Let's take a closer look at the cosmic calendar's entries. Imagine the universe as an unlit stage, a black canvas waiting for the first stroke of paint. Now, fast forward to the 14th of January. This is when the first stars ignite, their light piercing the cosmic darkness. These are not the stars we see in our night sky today, but the very first generation of stars, more massive and short-lived than their successors. Their lives end in spectacular supernovae, seeding the universe with the elements necessary for life. As we continue our cosmic journey, we reach the 15th of January. On this date, galaxies begin to form, vast islands of stars held together by the unseen hands of gravity. The universe starts to take on a structure, a cosmic web of galaxies strung across the vast expanses of space. The Milky Way, our cosmic home, is thought to have been born around the 1st of May. It's a barred spiral galaxy, one of countless billions in our universe, each with their own unique story to tell. But the story doesn't end there. Over billions of years, galaxies do not remain static. They grow, they evolve, they merge and interact. Each event, each cosmic dance, leaves a mark on the galactic canvas. The formation of stars and galaxies is not just a historical event, it's an ongoing process. Even as we speak, new stars are being born in nebulae, the stellar nurseries of our galaxy. And galaxies, though they may seem eternal, are constantly changing, evolving, shaped by the relentless march of cosmic time. This is the essence of the cosmic calendar. It's not just about marking dates and events, but understanding the grand narrative of our universe. It's about seeing the cosmos not as a static backdrop, but as a dynamic, evolving entity, teeming with activity and change. And thus, our universe was lit up with the birth of stars and galaxies. Now, let's turn to a date that's particularly close to home. On the cosmic calendar, the emergence of our home planet Earth occurs in the last quarter of the cosmic year, around September. The Earth's formation was a spectacle, a swirling mass of particles and dust gradually coalescing into a solid body over millions of years. Then, on the cosmic calendar, life begins to stir. It's around the end of September when the first simple single-celled organisms make their appearance. These primitive life forms, called prokaryotes, are Earth's very first inhabitants. They pave the way for the more complex life forms that would eventually inherit the Earth. Let's fast forward to November. This is when the first multicellular organisms come into the picture. It's an important milestone, setting the stage for the diversity of life we see today. By mid-December, complex organisms with specialized cells begin to emerge, marking a significant leap in the evolution of life. Now keep in mind, all of this doesn't happen overnight. Each day on the cosmic calendar represents about 40 million years. So when we say life emerged in November, we're talking about a time span of hundreds of millions of years. The first land-dwelling organisms, the pioneers of terrestrial life, don't appear until the last week of December. And the dinosaurs? They don't show up until the day after Christmas. The emergence of humans? If we're sticking to our cosmic calendar, you'll have to wait until the very last day of the year, December 31st. And even then, we don't make our entrance until the final minute of the last hour. On this cosmic scale, the Earth is just a newborn and human life a blink of an eye. This perspective reminds us of our fleeting existence in the grand scheme of the universe, and yet, how remarkable it is that life as we know it has managed to thrive on this tiny blue dot we call home. So, where do we fit into this vast cosmic timeline? Let's squeeze the entirety of human history into the cosmic calendar. If the universe's existence is represented by a single year, human history is barely a blink. It's surprising to realize that all of human civilization, every empire, every invention, every human who has ever lived, fits into the last few seconds of December 31st. The first humans appeared just about 2 seconds ago in cosmic terms. The pyramids of Giza? They were built less than a second ago. The Renaissance, the Enlightenment, the Industrial Revolution, all happened within the last split second. And our personal lives? They barely register. We exist for a cosmic heartbeat, a single pulse in the vast rhythm of the universe. Yet within that fleeting moment, we've managed to make a mark, to understand our universe, and to dream about the future. In the grand timeline of the cosmos, human history is but a fleeting moment. What does the future hold for our universe? This question has been at the forefront of human curiosity for centuries. The cosmic calendar, our timekeeper for the universe's history, may provide some insight into what lies ahead. If we follow the cosmic calendar's rhythm, we find ourselves in the last few seconds of the cosmic year, with the entire future of the universe stretching out before us. But what does this future look like? What can we expect from the universe's next cosmic seconds? One theory that scientists have proposed is the concept of the heat death of the universe. This theory suggests that as the universe continues to expand, it will eventually reach a state of maximum entropy, where all matter and energy are evenly distributed. At this point, no more work can be done, and the universe will effectively die from a heat death. This might seem bleak, but remember, on the cosmic calendar, this is billions and billions of years into the future. But the heat death is just one possible ending. Other theories suggest that the universe could undergo a big crunch, where it collapses in on itself, or a big rip, where it tears itself apart due to the accelerated expansion. In terms of cosmic structures, the future may see the birth of new stars and galaxies, the death of old ones, and the constant dance of celestial objects in the vast cosmic ballet. The universe's future, like its past, is a story of creation and destruction, beginnings and endings. Regardless of which theory proves accurate, one thing is certain. The future of the universe is as vast and mysterious as its past. We, as tiny specks on the cosmic calendar, have the privilege of bearing witness to a fraction of this grand cosmic journey. And who knows, perhaps our understanding of the universe and its future will change as we continue to explore the cosmos. So let's keep looking up, keep wondering, and keep exploring. After all, the future of the universe is as vast and mysterious as its past. What does this all mean for us, mere specks in the cosmos? You may ponder. We are but fleeting moments in the cosmic calendar, our entire human history condensed into mere seconds of the universe's grand timeline. Yet this comprehension shouldn't evoke despair, but rather a profound sense of awe and curiosity. Our existence in the grand design of the cosmos is not negligible, but rather integral. We are the universe experiencing itself, a collection of stardust capable of pondering our own origins. The breadth of cosmic time serves not to diminish our significance, but to highlight the marvel of our existence. Indeed, the vastness of the cosmos provides perspective, a grand stage upon which we play our brief but poignant roles. It is a call to seek, to explore, to understand. For as we delve into the mysteries of the universe, we are, in essence, exploring the depths of our own being. In the grandeur of the cosmos, we find not insignificance, but a call to seek, explore, and understand. So, we've journeyed through the cosmic calendar, from the Big Bang to the far-flung future. We've witnessed the birth of stars and galaxies, seen the emergence of our planet Earth, and found our place within the grand cosmic timeline. We've traced our roots back to the very beginning of the universe, and have looked ahead to its possible end, the heat death. We've seen how the entire history of the cosmos, billions of years in the making, can be compressed into a year-long calendar. We've explored how every moment, from the formation of the first atoms to the rise of human civilizations, fits into this expansive scale. We've reflected on our brief existence in the cosmic timeline, a mere blink in the grand scheme of things. Yet despite our fleeting presence, our curiosity and thirst for knowledge bind us to the universe in profound ways. As we close this cosmic journey, remember, we are all stardust, part of this vast, interconnected universe.